Hello, I am Brandon Capaccio and my partner is Juan Angel Ibarra. Today, in this video, we will explain how the algorithm for converting arithmetic expression from index notation to postfix and prefix notation works using the data and data series color stack. The program is implemented with Java and was developed as a case study for the data series course. First, let's understand the three types of notation. Index notation is one we use normally. The operator goes between the brackets. For example, A plus B times C. The problem is that the computer needs to set rules to evaluate it correctly. And that's why we convert the expression to other notation. Postfix notation. We're also known as reverse Polish notation, like the operator after the operand. For example, the operator open parenthesis A plus B plus parenthesis times C becomes A, B plus C times. Prefix notation. Place separator before the operands, and the same expression becomes thing plus A, B, C. This notation eliminates the ambiguity and don't need to parentheses. And they are to explain compilers, scientific calculators, and expression evaluators. The program has the three main classes. The main class asks for the user for the case number and calls the probot method, which creates an instance of expression and print results. The console EU class handles the console input and output. The most important class is expressions. It receives the index string and as an attribute and has the methods and apples fija and upper fija, which perform the conversion internally. It uses Java stacks class to manage the stack. There are all three helper methods, as operando, is operator, and is program, which classify each character of the expression. Now, let's go to the heart of the program, the shooting your algorithm, which converts it from infix to postfix. The algorithm goes through the expression character by character, applies the five rules. First rule, if character is an operand in a letter of digit, it goes directly to the output. Second rule, if it's left parenthesis, it's language put onto stack. Third rule, if it's right parenthesis, we pop operators until we find the left parenthesis, adding the temp to the output. If there is no left parenthesis to be found, we throw error 1. Fourth row is an operator with pop operators of equal or greater priority to the output, and then we pass the current operator. Fifth row. At the end of the traversal, we empty the stack to the output. If any left parenthesis remains, we throw error 1. The program also uses flag scaling, spare operator to detect the malformed expressions. Section 5. Let's try the case 1, which expression open parenthesis A plus B plus parenthesis times C. We start with the empty stack and the empty output. We read the left parenthesis and push it. The stack now holds the parenthesis. We read A, it's an operand, so it goes straight out. The output is A. We read the plus sign and this operator, so we push on top of the parenthesis, the stack holds parenthesis and the plus. We read B, it's an operand and goes to the output. The output is AB. We read the parenthesis, we apply the pop until we find the left parenthesis. We pop the plus and add it to the output. Then we discard the parenthesis, the stack becomes an empty. The output AB plus. We read the times, it's an operator, the stack is empty, so we push it. We read C, it goes straight to the output. The output is AB plus C. At the end, we empty the stack. We pop the times and add it to the output. Postfix result is A, B plus C times.
Plus C times prefix. The upper fija method takes the postfix A, B plus C times and converts it to prefix by reading left to right. Using a stack of strings for each operand, we push it as a string. For each operator, we pop the right operator fix, then the left, combine them as an operator, plus left plus right, and plus the result. We read the up and push is a string that stacks hold A. We read B and push it. The stacks hold A and B. We read the plus. We pop B as the right, pop A as the left, and from the string A, B, IB. We push it, the stacks hold A, B. We read the C and push it. The stacks hold push A, B, and C. We read the times, we pop C as the right, pop plus A, B as the left, and from the string times plus A, B, C. Prefix result times A, B, C. Section 7, case A. A plus B times C minus B divided by A, postfix. Case 2 demonstrates precedence handling without parentheses. The expression is A plus B times C minus D divided by A. We read the A and it goes to the output. We read the plus and push it since the stack is empty. We read the B and it goes to the output. We read the times, the top of the stack is the plus, which has lower priority than the time. So we just push the time on top. We read the C and it goes to the output. We read the minus. The minus has priority 1, the same as the plus, since their operations of equals or greater priority on the stacks. We pop, first the times come out, then the plus and they go to the output, then we push the minus. We read the B and it goes to the output. We read the divide. The top is the minus, which has lower priority, so we push the divide on top. We read the A and it goes to the output. At the end, we empty stack, the divide comes out, then the minus, postfix result, ABC times plus DA divided minus. Section 8, case 2, ABC times plus DA divided minus prefix. We apply a prefija to the previous string. We push the A, then the B, then the C. We read the times. We pop C as the right, B as the left, and from times BC. We push the stacks hold A and times BC. We read the plus. We pop times BC as the right, A as the left, and from plus A times BC we push it. We push the B, then the A, where we read the divide, we pop A as the right, B as the left, and from divide BA, we push. We read the minus, we pop divide BA as the right, plus A times BC as the left, and from minus plus A times BC BA. Prefix results minus plus A times BC divide BE. Section 9, case 3, A plus times B error. Case 3 is the malformed expression as expression A plus times B. The espera operando flag is what catches this error. In the first step, we read the A, the flag is true, we expected an operand, and that's what arrives, so it's fine, the flag flips to false. In the second step, we read the plus, the flag is false, we accept an operator, and that's what arrives, so it's fine, we push it, and the flag flips back to true. In the third step, we read the times, the flag is true, we're expecting an operand, but an operator arrives. It files and runtime is thrown with the mesa error 1. Other cases than trigger error 1 are expressions that start with an operator like I times plus B on the end, on that the ends with operator like A plus B times unbalanced parentheses like open A plus B without closing, or A plus closing without opening, or a disallowed symbol like A plus B at sign C. The main classes catches the runtime exception and print the error message to the console. Section 10. Results summary. The three test cases produce exactly the results the assignment specifies. Case 1 with the infix open A plus B close times C gives the postfix AB plus C times and the prefix times plus ABC. Case 2 with the infix A plus B times C minus B divided by E gives the postfix ABC times plus BE divided minus and the prefix minus plus A times BC divided BE. Case 3 with infix A plus B times throws error when both of postfix and prefix. And then section 11, conclusion. The stack is the data structure that makes this conversation possible. It respects operator, precedence, and parentheses nestings in a single pass. The Summing yard algorithms runs in order of n, linear time and space. The AppFija method is elegant. It reuses a postfija and adds a second pass with a string stack to build the prefix form. Error validation is integrated into the traversal, not as a separated step. These techniques are the foundation of modern computers, interprets, and calculations. Thanks for watching.
Thank you.